I'm Tom Gallivan. I'm with ConvergeIO. We're a software-defined storage startup. We're reinventing storage, and that's pretty critical because if you really think about it, storage hasn't changed since the dawn of the computing industry. And that's what I'm going to go into today. The pace of change in our industry is unprecedented. We're dealing with massive technology advancements, but I think even more importantly is the generational change and transition that's happening between my generation and the millennials. As business models are changing, access patterns are changing, we're dealing with globalization, and usage models are changing across the board. And, okay. What I want to say is that we're talking about data-defined storage. And the industry has been talking about storage-defined data for 30 years. Now, just think about that a little more carefully. The industry has been driven by storage vendors who have taken a storage device approach. They've taken a file system approach. They've taken a proprietary approach. All those elements are taking a completely different approach to where the cloud is going, to where Google came from, to where Amazon is, to where Microsoft is even heading. So I'm going to paint a little context about data-defined storage and what we're doing to unleash the power of the developer, the power of the individual to actually create content and move content and not be bound by storage, because we all know storage is a huge problem and it's very expensive. So I can't talk to the NAB without having some kind of corollary with the industry. And for me, the disruption that 3D caused is what's happening today in the technology landscape. I've broken these 3Ds down into discovery, devices, and data. And I'm going to set this context to show you why the storage model of the past is not going to work in the future. So discovery, for me, discovery is equal to search. Google changed the world with search. But they also changed the computing landscape because they did it on their own. They didn't buy special purpose servers and workstations. They built their own. They said they could use commodity components. Everybody in the computer industry said, no, you can't. They did it. They used open source software. People said, why would you use that stuff? That's not safe. They did it. The move towards commodity infrastructure and open source software has changed the dynamics in the computing industry. All you have to do is look at what's happened to Amazon and Facebook, two more pioneers in the discovery phase, which I call search. Facebook searches for individuals, Amazon searches for items. So information, items, individuals, it's all search. It's all scale out. It's all based on commodity infrastructure, and it's based as much as possible on open source software. Now, what some of them created, which is even more ingenious, was I built this massive infrastructure. Now, how can I use that infrastructure when I'm not at 100% utilization? They said, well, I'm going to start offering these compute cycles to clients. So what did Amazon do? Well, Amazon created Amazon Web Services, and as you heard earlier today from the Google people, they're now offering unlimited compute cycles per minute, per day, at your discretion. So developers can work 24/7. They can work in India. They can work in London. They can work wherever they want as long as they have an internet connection. So the paradigm for computing has changed. It's now unlimited. What used to take a year of planning to build a hardware infrastructure for a specific job can now be done in minutes. There's no need to have a proprietary compute infrastructure. You might want to have it in your on-premise because you're afraid of security, but as you've heard today from Microsoft, from Google, and from others, they are building world-class security boundaries into their systems, and they're willing to have you test them. So Amazon has built a $10 billion business providing compute resources and storage solutions to industry. The others don't release their specific dollars, but Amazon has actually broken it out. Last quarter, they did $2.4 billion. So they're on a $10 billion rate. That's a significant shift from a few years ago. In case you haven't seen what their data centers look like, this is a Google data center. It's all commodity components. It's all based on standard off-the-shelf parts. They've taken a data center approach. You know, between Facebook, Amazon, and Google, they each have over 1 million servers in their data centers around the world. They are now the largest consumers of commodity infrastructure on the planet. This compute infrastructure is being driven by devices. None of us would have imagined several years ago having supercomputers attached to ourselves every day. Our mobile phones, our smartphones, how many email accounts are we getting? Are we watching videos? I mean, my kids don't even watch television anymore. My kids, they go to YouTube and watch the news, or they watch their feeds on Twitter. It's all about devices, it's all about video, and it's all about content. This content is growing at significant rates, billions of devices, millions of queries, millions of transactions, all of this just complicating the whole storage and data management issues. All the industry pundits, all the reporters will tell you that we're growing data between 50 times between 2012 and 2020. So I learned in doing some of this work, you know, what a zettabyte was. Does anybody know what a zettabyte is? It's 1 billion terabytes. Do you know that they say in 2012 there was 2.8 million zettabytes, and by 2020 there's going to be 40 million zettabytes. That's astonishing. I remember megabytes. Megabytes were a big deal when I started in the computer industry. Now we're talking zettabytes. So your data is important. The security of that data is obviously even more important, as you've heard today, you've heard with the FBI, you've heard with Apple. That data has to be protected. But what it's really doing is it's creating this total transformation of business process across the landscape, specifically around application development. There's a whole next generation of agile development called DevOps, and people are moving towards real-time integration with microservices and containers, and we're trying to figure out how do you put speed into execution. Speed is everything. It's all about when can I get my product to market, when can I get my data to analyze to get to my business decision faster. And today's storage can't support this new process. It can't move fast. It's locked in a network storage model that doesn't scale with modern application development. You can't just move files from the developer that's in Mumbai to the QA group that's in China to the production environment that's at AWS. It's extremely hard. And people, if your data is stuck in a SAN or your data is stuck in a network attached storage system that's got a proprietary file system, that file system doesn't talk to this file system. And all of a sudden your data is just stuck. So business transformation is happening. Real-time agility needs to happen, and storage needs to move towards that model. So I say, what is the data dilemma? Well, the data dilemma is I've got unlimited processing now. I can get access through GCE or AWS or Azure. I get as many processors as I want on demand, and I know exactly what I pay for it. I also know that I've got data coming in zettabytes that I need to manage, and I need to protect, and I need to have a plan for how I'm going to do that. I know I've got privacy concerns. I've got to have DR. I've got to have backups. I know I've got consumers that want to access that from anywhere on the planet. And I also know that I've got data in multiple facilities and multiple locations around the world. So, is my data from AWS able to move to Azure in London, or is my data at GCE, can I take that data and move it over to another cloud provider if I want to? That, you should go ask your provider that. That's a very difficult problem. It's a big challenge as we move into this multi-cloud. Primary reason is your data is locked. Most of it is in proprietary solutions. So you're basically stuck in a SAN, you're stuck in an NFS mount, you're stuck in a NAS environment, and you basically are at the mercy of the storage device that you've selected. Now, storage device manufacturers will say, I'm better for performance, I'm better for streaming media, but what they're not telling you is that you're basically locked in. So your data's locked. Your data is also, I say dumb, because it's just bits. It's ones and zeros. There's not a lot of intelligence in that data. And you basically need smart data if you're going to work in a internet-timed business, which is speed and agility. And data management's complex. As I mentioned, you have too many stacks of vendors involved. You have backup software, you have disaster recovery plans, you have compression appliances, you have deduplication appliances, you have 15 different vendors in the mix. And that complexity, as someone mentioned earlier, is with 50x growth in data, half the resources to manage it, and half the time to get the job done, how is anyone on the world ever going to get the job done? They're not. So there's just disaster waiting to happen. Everybody says I need a backup plan because I need, to make sure I can recover from failures. But where does backup usually fall? It falls on the bottom of the list. Why? Because it costs money and it takes a lot of time. And people never get to it. And then the only time you know when you want to have a backup plan is when you've lost data. So we are building what we call an intelligent data engine. And we fundamentally believe that an intelligent data engine is software-driven. It supports multiple cloud infrastructures. It allows you to scale performance in a multi-tenant environment. So you can actually run multiple applications and manage your data globally with no borders and provide protection at all times. So you can select the level of protection you want. You can have 2 copy, you can have 3 copy, you can have parity. You can have all the technical things that storage vendors have provided for years, but it's all done through software. So what do? We unlock your data. We abstract the data from the actual hardware. So the software abstracts your data. It's your data. So you take control of your data. We add intelligence to the data. So it's called metadata. You've heard, I know you all know about metadata from shooting film and cameras, but there is metadata inside of your data that you're storing. So we've got extensible metadata so that customers can customize what knowledge they want to know about their data. So someone can actually take an inventory of their data across the globe. So I can know what data is on AWS, I know what data is on Azure, I can pull all that data into a database, and I can actually now understand what data I have in my organization. And the third thing that we focus on is around automation. So taking the complexity out of storage. As I mentioned, you can't have 50x growth in data with half the resources and finish in half the time. It's physically impossible. So you have to automate. You have to take out all the protocols. There's no developer needs to understand that he needs to mount an iSCSI drive or that he needs to even do an NFS mount. There's this thing called containers. You can create data containers. You can Docker, the fastest growing container technology in the planet. 2 million downloads in the last year. Storage is becoming a feature in application development. An application developer just says, I want 10 terabytes. Give it to him. Give it to him protected. Give it to him mounted in a Docker container. Give it to him on an IP address that he understands. Let him move that container from developer A to developer B. Let him just move that file with a single command. That's what our intelligent storage engine will allow you to do. That complexity of understanding SANs and NAS and compression and deduplication and protocols is not required. A developer doesn't want to do that. We're talking about empowering developers, content creators. You want to empower those people by just letting them create that content. Give them the information that they want, give it stored, give it protected. So I went for a guy who was a little older than 200 years. But the only way to do this is kind of what Google did with search. We started from the ground up. We didn't assume all the things that we've done for the last 25 years in storage. And that's the difference. There are people that are relabeling network storage today and calling it software-defined storage. But if you really look at the underlying model, they're all implementing network storage models. And they're still requiring significant expertise. They're still requiring understanding of file systems and NFS mounts and iSCSI attach and all that detail that's really not required. And looking to the future, it is cloud enabled and it is software driven. And the industry needs to take control of your data because your data is where your dollars are. It's not about your storage devices, it's about your data. And your data is what's valuable. We are going to work with the ETC and work on that extensible metadata, and we're going to build in the security profiles that they are promoting to protect that content and to make that data secure for all constituents in the media industry. Thank you.
Do we have any questions out there? I know that I actually have a bunch of feedback. You're talking about containers, Docker, CoreOS, and actually K8 or Kubernetes would be the last piece there for fleet instances.
Mesos and Kubernetes,
Yes, absolutely. So we 100% believe in this technology. This is what we think is the future. It allows you to take your internal infrastructure and port it to the clouds with little redevelopment work in comparison. And if you go and you look at something like K8, K8's the technology that actually powers Google search right now. And basically that when you ask a question, it spins up one of these containers so fast, spins it up, answers the question, and spins it down, which is utterly mind-boggling that it can do these things so quickly and just really radically changes it. So like you said, it helps.
So Kubernetes is the infrastructure orchestration tool that Google uses internally that they've now made open source. And there's plenty of information online about Kubernetes. Mesos is another open source project that's also an orchestration tool. It's by Mesosphere. They have what they call the DCOS, which is the Data Center Operating System. All of these are tools that are out there that are promoting the orchestration of this cloud-based computing and enabling people to spin up and spin down. And you know, if I assign 10 CPUs to this job and one fails, they automatically bring another one in. What we're doing from ConvergeIO's perspective is we're adding that storage layer to that ecosystem, and then we're allowing people to move those volumes of data to match where the CPU job is, and to be able to have the agility on storage the same way you would with CPUs and RAM.
It looks like we have a question.
Just to be clear, you support migrating. So if I have my stuff sitting in Google's cloud and I decide that I want to migrate it to Azure tomorrow, you can make that happen easily?
Well, I wouldn't say it's easy, because I wouldn't want to lie, but it is possible, yes.
So you wouldn't have to completely redesign what you're doing as long as you structured it in that format before.
Should go.
Yeah.
Yes, correct. Yep.
Yeah. And I think this leads to both his simplicity side. You want to simplify how the storage interacts and moves. Like we've talked, both the other two speakers, Guillaume and Cronin, said earlier, you have to create that layer of intelligence on the storage itself to move between these different layers. You're not going to want to spend all of your money on, I don't know, even in a major cloud. You might want some local stuff. You might want some local object storage, and having that intelligent layer is really
And you have to
critical.
support today's infrastructure as well as cloud. So, you know, there's some people that just support cloud, and there's some people that just support on-premise. You know, what we're envisioning is it has to be a solution that works on-prem with your current infrastructure as well as in the cloud. And therefore, you're giving customers that freedom to use their existing infrastructure until they, as someone earlier said, at some point they might go all cloud.
Yeah, so it allows it to become invisible behind the scenes eventually.
Single approach to how you're managing your data.
Yeah. Well, thank you so much.